Okay. So, yeah, I had a little bit of a dilemma here in that we have a bunch of collaborators and a bunch of them are actually presenting in the session. So what do I talk about without showing you the same maps again and again? Um, and I decided to focus more on the oh, um, testing. Okay, the programmatic sides of things, how we were funding things here in the US, and then I'll go into a little bit of discussion of the technology that we've been working on. So this is just basically showing the different programs that we've run. They've been focused more on trying to constrain the Great Basins of Antarctica, particularly East Antarctica, which were poorly constrained back in the international polar era, but moving on into focusing more on the grounding zone area with a number of international collaborations. But the international collaboration aspect has been absolutely key for expanding this across Antarctica. I'll talk a bit about the funding models in the US. There is no central research institution in the US that combines the logistics and the research. The closest you have to that is NSF, which distributes money and handles the logistics, but doesn't do the research in-house. That's all done at universities, and it's driven by proposals which are hypothesis-based, limited duration, and there's no real overarching strategy beyond what happens in these kind of forums between individual PIs. If you don't have a clear hypothesis, it's unlikely that you're going to get funded. Now, there are other approaches. There are the large centers, things like CREASIS in the past, things like the big initiative with UTIG, and the Coldex, which I'll talk about a little bit later, which has, by definition, nothing to do with rings, but may have some application. And then there are the instrumentation grants. I believe IcePod was funded by a major research instrumentation grant. The ultra-wide bandwidth system that AVI has been using also had its origins in that. But again, that's not part of an overarching strategy beyond what the community puts together. So overall, not great for systematic surveys, not great for an explicit integrated plan. NASA is a little bit different. They're very mission-oriented. They're top-down, and then you're competing with the NASA research centers, which have very good scientists for the same pool of money. The funding is very much a matter of how close you are to space hardware, maybe data if you're lucky, but yeah, you really need to appeal to the latest mission, which are part of grand strategic initiatives which are put together on a decadal basis. I would say, this is a personal observation, there have been some tensions with OPP when it comes to the NASA NSF Office of Polar Programs when it comes to interactions in Antarctica. Occasionally NASA gets kicked out of Antarctica for a period of time, and then they get back on better terms. And there are constraints on international collaboration. China by law, NASA by law cannot work with the Chinese government, which is a really unfortunate obstacle. Their PR game is excellent though. So they're great for huge systematic surveys if you can point to the spaceship. The other thing out there, we have an abundance of bored billionaires now. So philanthropy, it can be quite sustaining in small amounts. You know, at the university level, the routine gifts, that has been really foundational for our program. It's also quite flexible. In larger amounts, it tends to be a little bit more whimsical. You know, you might get a large piece of instrument funded, but then no money to do much with it. Or a one-off campaign and then nothing to really follow on from it. But we found it really key for sustaining technical staff and graduate student productivity. So just going through the classification of how we've been funded, the blue here is NSF, and then green was NASA. And you can see there's been this little evolution over the last few years. We do have a lot more blue on here. Again, it's not relevant for rings. Just a few points. For these first few years, especially when we had a large amount of money coming in from the UK, and with NASA, we were able to directly contract the aircraft. And so it was not being run by the international programs, and that does provide a level of international flexibility on getting between programs. The second point I'd make is, without naming names, you can see that the concentration of colors tends to correlate with changes in administrations. When parties of one flavor are in power in the US, it's easier to get some of this federal funds, and then it dries up and you look for other approaches. So it does oscillate. The other thing I'll note, the numbers there indicate that the proposal that was funded, that was the number of attempts we took. You have to be patient, and yeah, so it takes a year for these things to go through review. On the NSF side, there's logistical review that can take another year. I had a proposal that was eventually funded in 2017 with a 2014 submission date, and they ended up taking all the logistics away. So it became an analysis grant. But yes, patience is needed. Now a few points on the logistical side of things. The experiences that we've had with IceCap, the permanent station, yep, fuel rich, really easy transport paths to there, and repeat observations are straightforward if you're based in these areas. But they can be far from interesting targets, and you're also in logistical hubs, so you're in competition. People like to steal your plane from medevacs. And you're also, most of these stations are down at sea level on the coast, and the weather is horrible there. So that can shut you down a lot. Something else we've done, especially in the US program, is the temporary field cap in the interior. And you have ideally close to the target. And perhaps more importantly, you are the big game in town, and you don't have to worry about the logistics, and you can just get your stuff done. However, the weather delays can be sensitive in setting the base up. So many delays, long deployments in getting the infrastructure put in, very fuel intensive once you count supporting the field camp, and it's difficult to do a repeat survey after all that effort. So optimal for rugged aircraft. Some programs, like British Antarctic Survey, they don't need the showers and whatever, so it becomes a little bit lighter footprint. But in the US program, yes, you need the cook and the microwave. And then another approach is to have a station that moves. Use an icebreaker, and you can get close into your target. They're rich in fuel, and it's pretty hard to stop an icebreaker by definition. And then long-term repeats, you can get into these areas. You are competing with other science, time is tight. Your icebreakers are a vital piece of the logistical picture, so that has to be taken into consideration, or you have to go rescue a fishing boat. And extremely long deployments, and also sea ice can also mess with you. So I think Won-san will be talking a little bit more on this for the helicopters. Now, a little bit of the technological and innovations we've been doing, working with the Koreans. We've actually been able to go in and refly some of the old original Agassiz lines from 2004 over a couple of seasons, and we're looking for changes in the basal hydrology. This is work that Lucas Beam is working on right now. So this is something that we might want to think about more on rings. We have a lot of data now, and it's getting older, and that age can be a good thing. We can see change. The other thing that we're looking at is 60 megahertz multipole radar. 60 megahertz, the wavelengths are long, 5 meters, but with the helicopter configuration, we can actually do this. It's still in development. We nearly pulled it off last season. COVID intervened, but this will actually be deployed over Devon IceCap this coming Arctic field season. And then a little bit about Coldex. So Coldex is new NSF Science and Technology Center that we been funded with a bunch of other universities. It's a very high NSF priority, which is great. It does make you the big thing in town in McMurdo. And we have 2 airborne field seasons starting at South Pole. One we'll be doing this season is basically a reconnaissance, really filling in the area between the old AGAP survey and South Pole. And then based on the results of that, we'll do focus surveys getting down to 3 kilometer line spacing, which will then be the basis for follow-up groundwork. So complete opposite of what Rings is all about, but the technology is a big part of the Science and Technology Centre. And I'll just add that depending on how you count, this was the third or fourth attempt to pull off the survey. South Pole is a fortress, and you need to be, really, really clever to get in there. And Renee and Fausto can tell you all about that. So the technology, so we're actually integrating with the University of Kansas as part of this. The first season we'll be flying the Center Array, and it will be basically accumulation radar, but turned into an array system, which will be capable of swath mapping, but also this new technique of repeat interferometry, going back and reflying lines between seasons and looking at the vertical strain rates. We've been actually talking to John Sontag, who some of you might know about, improving our cross-track positioning. It's driven by this repeat interferometry. From the helicopter side of things, we will be repackaging the Basler racks to make it more efficient, using the experience we've gained using the helicopter. We're working on reduced footprint gravity. Various international events have made that a little bit more complicated, but hopefully towards the second season we'll be in a better state there. And then also we have the opportunity of integrating the Kansas's snow radar as well as kind of a secondary science objective. And that's from the talks that were yesterday on the importance of accumulation, surface mass balance across Antarctica, may be worth some consideration there. And all of this technology should be quite useful for rings objectives as well. And then just some other lessons, and I'm over, so apologies. So great technical and programmatic staff, sustaining them over the course of these long-term projects. This is something that's really important, and we shouldn't forget. Something probably pretty key for rings, early negotiation of papers, including the role of ECRs. Getting that up front and clear, I think is really important, and we've learned some lessons there, both positive and negative. And then this was a point that Jamin alluded to in his question earlier on. It would be good for a multinational effort like this to coordinate better on things like shared codes of conduct, and maybe there's some training that could be done before field season. So it's not too onerous, but yeah, there are some recent papers that kind of rip the Band-Aid off on the state of affairs in Antarctica. And I think we're doing better, but there's still work to be done. So that's my presentation, and I think Joe McGregor is next.